begin the recording, share my screen, and over here on GitHub. Yes, good morning, everybody. Welcome to our next week of data structures. So last week we had this topic 8 AVL tree as our most recent folder on GitHub. This is still the most recent folder on GitHub. I'll post the topic 9 heaps folder for Wednesday's class. But today in class, what we're going to do is we're going to finish up going over these Posix practice problems. Again, last week we finished this Posix Ii practice quiz. If we come here, it looks like this beginning with the pipes and then going on to all the different quotation marks. And your quiz on Wednesday this week will be about only this first Posix Shell 1 quiz. So this week's quiz, only the Posix Shell 1. And today in class, we will finish going over the Shell 2 material. You will not have that on your quiz this week. That'll be the quiz for next week. And then, yeah, this first Posix Shell quiz here, starting off with pipes. Your lab last week, dealing a lot with pipes and doing some cool stuff for Twitter data analysis with that. Hopefully that gave you a sense of maybe some of the motivations for why we're talking about these things in Posix Shell and the terminal or bash, all of these things sort of synonyms for each other. Again, our upcoming labs and eventually this homework assignment on large Twitter analysis will be focusing on the why we care about the shell and the terminal, talking about all the cool things that we can do with it. But then these quizzes are going to be focusing more on the how and the what, the actual mechanics of working with the terminal, making sure we understand all these weird edge cases about how things can go wrong, so that when you get to the labs and the homework, you'll be able to focus on the cool application parts. And again, like we've seen before, or what like we've been talking about with these practice quizzes, there are a lot of weird edge case stuff. There's no new handouts for today. All of the material that we're going over is stuff that we've had before. So again, we finished the Posix Shell 1. That is the quiz for Wednesday this week. And then we're going to finish talking about this Posix Shell 2 today, which will be the quiz for next week. Your next, so that's the main administrative announcement for today. Other administrative announcement is related to the homeworks. Again, there'll be a slightly different format for this next homework assignment, this heap homework assignment. We'll talk about that though on Wednesday after this AVL assignment is due, which is tomorrow. Any questions about anything administrative before we get into the technical material for today? Okay. I'm going to take us over to the terminal here, and we'll be spending most of the time today in the terminal. I'm logged into the Lambda server. Let's redo my there we go. Our initial reset the Lambda server for each quiz problem command. And we'll do a little bit of review of the Posix Shell terminal stuff that we've talked about last time, and then we'll get into the new material for today. The main interesting thing about, or the main weird edge case that we talked about from the Posix quiz 1 is about the different the different quotation marks and how they behave. So here, if we have a variable, we'll call it test equals hello world. Again, in the shell, anytime you're creating a variable, you cannot have spaces around your equals sign. If you had a space after this equals sign, then the shell would think this is a command right here, a program that's being run, but we're not running a program, we're assigning to a variable, and so you cannot have spaces around the equals sign. If we do something like echo $ test, we access the variables with the $ like this. And if we put single quotation marks around it, the $ does not get expanded. But if we put double quotation marks around it, the $ does get expanded. So that's the first weird thing that we've seen. And the other weird thing is what happens when there are no quotation marks. If I do something like the echo command with no quotation marks, you can't really tell the difference between no quotation marks and with quotation marks. But with, say, the touch command, you can tell a difference. So I'll do ls first of all. We can see there's no files created down here. And then touch $test with no quotation marks. ls, this creates two separate files. Again, I can verify they're two separate files by piping that to cat. The ls command is the only command that we'll talk about that behaves differently when involved with a pipe. It puts every file on its own separate line involving when it's using the pipe like this. But with no pipe, it puts things on just a single line to make it a little bit more human readable. But this is actually the standard, more default output of the ls command. And here, this is with no quotation marks. So this variable is being expanded, on this line, this variable is being expanded. And because there's a space in the variable right here, we are creating two separate files. If we wanted to create only a single file, we'd have to put quotation marks around the $, and that tells it to create a single file that contains a space inside of it. So this is all review from the Posix Quiz 1. And then last time we were talking about, started going on to this first problem right here in the Posix Quiz 2. And here the interesting thing is, well, there's a couple of interesting things going on, but the first most important interesting thing to make sure that you are 100% comfortable with is how these quotation marks interact with this, it's called a here document. This double less than sign right here is called a here document. And this is a way of getting our input into a file. And we've seen this a bunch of times before in our previous quizzes, but now since we're focusing on weird edge cases in the terminal, we're going to be seeing the weird edge cases related to this here document. And I'm going to go ahead and type out this first problem. We'll go over it and see the weird edge cases here. So the very first line here is creating this variable foo equals hola. And let's go ahead and re-clear our screen to do this. So foo equals hola like this. Whoops. And then cat a whole bunch of things into this file. Again, the input redirection causes this information here to go into the cat command, and the output redirection right here, the greater than sign, causes those results to go into the quiz.sh file. So cat greater than quiz.sh here document in the single quotation marks. This will be very important here shortly, in the single quotation marks right here. And what we're doing is foo equals hello, check in this if statement if foo is equal to hello, and then touch the if command down here. So foo equals hello, if $foo equals hello, then touch if fee eof to end that here document right here. And oh, I have a typo there, so I'll press the up arrow, go back here. When you use the up arrow with the here document, it takes you back to that entirety of the command. And you cannot use the up and down arrows to modify the contents of this command right here, because that'll take you to previous and subsequent commands. You have to use the left and right arrows going backwards and forwards until you get to the appropriate spot. So there I have fixed that typo, added in that quotation mark. And touch is also misspelled. Typos everywhere. T-O-U-C-H. Thank you. Any other typos? So yeah, in the problem itself over here, we're using the double quotes in some spots, the single quotes in other places. In this case, there's no difference because there's no variables happening. If there's no $ in a quotation mark, no dollar sign in a string literal. We call these things string literals when you're specifically specifying the quotation marks. If there's no dollar sign in a string literal, then the single and double quotation marks behave the same. And the important thing at this point is to identify how this foo variable right here behaves, because there are two potential foo variables involved. We have this one up here where it starts as hola. If inside of my terminal session I do echo foo, then foo is equal to hola right here. Hola, so hola. But down here we have foo equals hello. And so the question is, this foo right here, what value is it going to take? Is it going to take this hello, or is it going to take this hola right here? In order to figure that out, we'll cat this quiz.sh, cat quiz.sh. So we will look at the contents of this file before we run this file. Coming back over to the quiz problem itself, it has an sh down here on line 9. So we're going to actually run this file, execute it. But before we do that, we're just going to look at the contents of the file. And strongly recommend while you're practicing or preparing for this quiz that you look at the contents of these files that are getting created by all of these terminal sessions, because it's not obvious what the contents of those files will be sometimes. And this is the way that you'll do it. Just immediately after creating the file like this, then cat like this will tell you the contents of the file. And in this case, when I look at the contents of the file, I can see there is a $ foo still inside of here. And so when I run this file, it will literally run these commands one at a time. Foo equals hello. And so at this point, because we say foo equals hello, here we'll substitute hello, and it'll do the touch if. We'll do an ls command, verify that we don't have an if file inside of here right now. We do have this quiz.sh, and then sh quiz.sh. Whoops. One more typo. Up arrow, up arrow, up arrow, up arrow, up arrow. In the shell, spaces are a little bit weird how they're working. You must not have a space after the equals and before the equals. You must have a space surrounding your square brackets here. So must have a space before the square bracket, must have a space before and after the square bracket over here. Hit enter. Now we'll rerun that. No error message. I type ls, and we can see that the if file was created over here because this foo got substituted in with hello right here. The variation on this, which some of the subsequent problems do, is what if we replace these single quotation marks, take them away? And so in this case, I will do the rm if right here, ls, the if file does not exist. I'll use the up arrow to come back to my cat command, and we will replace these single quotation marks up here, deleting them like that, hit enter. And now if I do cat quiz.sh, just look at the contents of quiz.sh, we can see that down here, when this command was being run, so not when the quiz.sh command is being run, but when this whole thing is being run, this here document is not inside of single quotation marks anymore. So any $ inside of there get substituted with whatever the current value of this variable is. And outside of the program, inside of our terminal session right here, echo $foo, the current value of this foo variable is hola. The current value of this foo variable is hola because one of the very first things that I typed in up here was foo equals hola right there. And so because there's no single quotation marks around EOF, it's acting like a double quotation mark string, and it does the substitution here at the time that you run this command. Therefore, we have hola here equals hello. That's going to be false. And so when I run quiz.sh like this, no if file is created. So the most common way people will make mistakes on this Posix shell 2 is you will see this EOF and treat it the wrong way with the single and double quotation marks. So pay very, very close attention to whether the EOF here, whether the EOF over here has single quotation marks or no quotation marks around it, because that will tell you how the variables get substituted in the problems. The next common mistake is when we're doing this cat command right here. This is creating a quiz.sh file. And at the very end, all of these problems are going to be ending with an ls command. It's common to miss that quiz.sh file. You're only focusing on the contents of what this program is doing right here. And so you're only focusing on whether the if command is, or the if file right here is created or not created. And so you miss that the quiz.sh file was also created, and that is going to be part of the output of this ls command. So make sure that you're putting the quiz.sh in the outputs of these commands. This is all still mostly review from last time. Are there any questions at this point? Okay. Then we're going to move on into some new material here. And in order to talk about these problems, I'm going to go ahead and reset here. In order to talk about these problems, I will, rather than going through exactly how the problems are formatted, there's a lot of things to type out for each of these problems. So I'm not going to type them out all directly. Instead, what I'm going to do is I'm going to be using Vim to edit these files directly and then running these files. So we'll be going over the high-level idea behind all of these sections in these notes, but we're not going to be running through each of these terminal sessions like exactly line for line. There's a couple of reasons for that. One is, again, it'll be faster for us to not have to type this out every time, avoiding typos, but also it'll leave these problems available for things for you to test your own understanding of the material, and you can come back to these problems to do that. As we're going over the material, though, I'll be structuring the topics that we're talking about, following the same pattern, the same outline, and so taking your notes in these appropriate sections is a good thing to do. In this case, what I'm going to do is I'm just going to add an else command right here. That's what the next problems down here, adding an else, and the else is going to behave the same exact way as you would expect it to do, that if this thing up here is true, then it'll do this right here. If this condition up here is false, then it'll do this condition down here. And we'll do an echo false. And I'm going to change these from touches to echoes. That'll give us a little bit faster feedback on what's going on here. And for all of these problems now, because I am just sitting inside of Vim and not using the terminal, we're not going to be testing this difference between the EOF with single quotation marks and no quotation marks at all. We're just going to be focusing on the contents of the file down here and what's going on in the file. So this is our new program. We're defining our variable up here. Simple if statement, check if these two things are true. And if they are, echo true. If they're not, echo false. So cat quiz.sh, there's the contents of the file. And I run that, we get true right here because hello substituted here. We get hello equals hello. Everything's good. Modify that. And so here we'll put hola inside of this foo. Now this condition up here will be false instead of true. And so we will do the else condition instead. And we'll echo false out here because this condition up here turned out to be false. And so we did not do this thing, we did this thing instead. Inside of the shell, there are many ways to negate a if condition. In Python, we would do something like add the keyword not. The not keyword is not something that exists in the shell. Instead, in the shell, we use the exclamation point to negate a condition. There's a very common thing in programming languages that the exclamation mark means the not character. So foo not equals to hello. Again, foo will be substituted with hola on the left-hand side. Hola not equals hello evaluates to true. Let's recat that out so we can see it. Foo not equal to hello, this right here will evaluate to true, so we will go inside here and do that. That's equal to true. The not character can also appear in front of the expression like this, the bang character in front of the square brackets, and it has the same exact meaning. We still get it equal to true. So the exclamation point doesn't matter whether it comes before or next to the equal sign, still negates the expression. Any questions so far? Okay. Yeah, the most of the stuff we're going to see over the next 5 or 10 minutes is not necessarily tricky stuff. So like there's not anything too tricky about this exclamation point. It's just once you have to see it, it's a little bit different, but then you'll be comfortable with it and probably not make too many mistakes with this material. I won't explicitly do the elif, but the elif behaves just like you expect. It's an else combined with an if, just like it is in Python. Section 1.2 is how we do ands and ors inside of the shell. So let's open up our quiz.sh again. And in Python, when we are doing ands and ors, we would do something like adding an or statement like that, actually using English language text. In the terminal, we do not use and or like this. Instead, we use the double and. That equals and. That should be a comment. And that equals or. What is that? I don't think we've explicitly mentioned this yet, but comments in the shell are the same as comments in the terminal. So these two lines right here are comments, not going to affect the behavior of the program in any way. When we're using the and the or, they go outside of the square brackets like this, not inside of the square brackets. And whatever conditions you have, the square brackets have only one condition at a time. So here, foo equals hello, and we'll add a very simple condition here. Hello equals hello. In this case, this entire condition like this will evaluate to false because the left-hand condition evaluates to false. And so it doesn't matter that the right-hand condition evaluates to false. We're going to skip this line right here and come down and do that line. So save that. We'll cat it for so we can see it, and we get the false down here because this is an and statement right here, two ands next to each other. So as soon as this becomes false, we don't even have to look at this over here. If we change that to an or sign, so for GGF ampersand XXI bar bar escape colon W Q cat quiz.sh. The only difference between this version of the file right here and this version down here is that I've replaced the ands, double ampersand with the double vertical bar like this. And in doing that, we'll see it will first evaluate this condition over here. It'll evaluate to false, and so it'll go over here, see that this evaluates to true, and it'll echo true down here. So sh quiz.sh, and we get true because this double vertical bar is an or, this double ampersand is an and. It's a little bit confusing that the double vertical bar means an or. So single vertical bar is a pipe, and the double vertical bar is or. So far, we know that the double ampersand is an and. Later on, not in this quiz, but later on, there's another meaning for the single ampersand. Has another meaning. We're not ready to talk about what that other meaning is yet, but we will see it later on. And so that's why we have to use the double ampersand and the double vertical bar here, because the single versions of those characters have totally separate meanings. And it's a little weird that there's like no semantic relationship between these two things. It's just for historical reasons, that's what people chose, and now we're stuck with it. But the key takeaway, or and separate out your conditions into multiple square brackets. Any questions about that? Caesar? Okay. So the question is, we don't have the single quotation marks around EOF, but you do have single quotation marks around foo like this. And the question is, what happens to this foo variable right here? Is that right? The answer is that this here document doesn't know like what the semantic content of this is at all. All it does is looks like it doesn't try to interpret this as shell or anything else. So the fact that we have single quotation marks around this means nothing from the perspective of the here document right here. And so when I hit enter and cat quiz.sh, you'll see that that substitution still happened. Our foo variable is currently equal to Ola, so that substitution still happened right here. Yeah, it's very tricky, like keeping in your head, there's multiple sort of levels of programming language going on here at once. And ultimately, one of the main thing that separates out like a really experienced developer from a, well, one of the things that separates out a good computer scientist from a less good computer scientist is the ability to have these like multiple abstractions in your head, or to work with these multiple levels of abstraction at the same time. And that's one of the purposes of this quiz, is to like get you that familiarity. But it is admittedly very, very weird. Takes a lot of practice to do this. But a great question. Any other questions about? Yes. Okay. The EOF, it doesn't matter at all what's inside of here. Like it will not, we don't even have to have valid things inside of here. Like we can just, like this is not a valid shell program at all. And when we run this, this is not executing this code. This is just creating a file that contains this code. And so because of that, it doesn't matter what is inside of here at all. It just finds if there's a $sign, there's no quotation marks up here. So if there's a $sign, it does the substitution down here. Yeah. And so, yeah, even if we had double quotation marks around this, doesn't matter, still does the substitution. Yes, Henry.
So the number of quotation marks does not matter.
Question is evaluating the equivalence between two strings. So here, if we're doing something like this, if Ola equals Ola, the question is, does the type of quotation mark matter between these two things on the left and right here? Is that your question? The answer is no. That internally, the shell program first evaluates all of the quotation marks, does whatever it has to do for those quotation marks. Then internally, it's all represented as a string, and it compares those two strings against each other. So the way that you get your string, whether you have quotation marks or no quotation marks or single or double quotation marks, doesn't matter. Doesn't matter how you get the string. So single or double or no quotes, or the you can have the $sign parameter expansion, or running programs, or the $sign variable expansion. Doesn't matter how you get your strings. Once you get the strings, it only matters the value of the strings. Good questions. Any other questions about anything so far? Yes. In the previous example, explain what? I'm not sure which example you're referring to. This? Question is, why does this right here evaluate to Ola? So previously, one of the very first things that I did in the terminal session was I said foo equals Ola. And so now when I do echo $foo like that, we get the Ola down here. Yeah, you're right that when I have this, so if we edit our quiz.sh, so it's now the quiz.sh, the contents of it, just setting foo equal to Ola. When I run that, it will not change the contents of foo in the terminal session itself. It only changes it in the contents, in the context of this program right here. There's like a mini terminal session here that's invisible to us, that's running in the background. And this terminal session inside of here would have foo equal to hello, but our main terminal session still has foo equal to Ola, and it doesn't get affected by whatever happens here. Anytime that variables are created or used inside of a shell script, they can't affect what we call the parent terminal process. Anything's in here that are happening inside the child, they can't affect the variables inside the parent. So the way to think about it is that just like in Python, we have functions with local variables, and those local variables can't affect the parent's local variables. It's the same thing in the shell. This has its own local set of variables, and it can't affect the variables in the parent process up here. Was that your question? Did that answer it? Okay. All great questions. Any other questions at this point? Okay. And as we're going through this, it's totally okay if you realize you have a question on things that we talked about 20 minutes ago to bring up that question. There's a lot of things going on in this shell, a lot of things that it just like the questions might not come to you instantly. So it's great to just revisit those old topics and ask them again. So this section 1.2, again, the main takeaway here, this is the and symbol, this is the or symbol, and if you have multiple conditions, you put each condition inside of its own set of square brackets. Coming down here, problem 10, it's introducing this new sort of command, condition-ish looking thing right here, true and false. If I come back to our quiz, let's go if true and $foo equals hello, then echo true. Phi for the opposite of if, so that ends our if statement right here. The true is like the true statement in Python, it will always evaluate to true. In the shell though, everything is always lowercase. You never use uppercase letters in the shell. Everything always lowercase in the shell, never uppercase letters. So true and false are going to be lowercase, whereas in Python, they are uppercase. Save that, cat the quiz, sh the quiz, run it. Oh. And once again, I made my mistake of in the shell, you have to have a space around this square bracket right here on the left-hand side. The right-hand side doesn't matter. This is acceptable. This is acceptable. This is not acceptable. I was getting an error message because I did not have the space right here. For the purposes of the quiz, you don't need to know that. All the code that I give you will not throw error messages. But eventually you'll be writing your own shell script, and so you'll need to be aware of that. So now we write that, run that, and we get true right here. This evaluates to true because the left-hand side of the and is true, and this right hand gets evaluated to true because foo here is equal to hello up here. If I change this, open that up, change the true to false like this, So now it's if false and this thing over here, run that, then it's not going to output anything because this condition up here is false. And so we never come down here and echo true right there. But if I were to change that and into an or like that, then if false cat quiz.sh, if false or this condition over here is still true. So it doesn't matter that this thing over here is false. And when I run that, it will print out true. So the false and true are do what you would expect them to do. The difference from Python is that everything is lowercase and they will not go inside of the square brackets because they are not evaluating a condition. They are the result of evaluating a condition. And that takes us end of section 1.2. Section 1.3, the not or the bang operator, we already covered that. And so that takes us all the way through section 1 onto section 2 down here. Any questions about anything so far? Yes. So parentheses are going to do what you would expect them to do. That so here the question is on problem 11, line 6 in this if condition. How do parentheses work? And so the parentheses will first evaluate this thing on the right-hand side. And so if bar equals salve, here bar comes from the bar right here, so salve. So this will be equal to true. So we'll get true. And so we'll have false or true and true. And so that'll evaluate to true and it'll do this touch if statement right here. There are some weird things about parentheses that we will see later on, but at least at this point, parentheses do what you would hope they would do, and they just group things together in order of operations. Yes. Yeah, so because there's an or right here, if this thing over here was true, then it wouldn't matter what was going on this side over here. And if this was an and right here, then both sides would have to be true. So this would have to be true over here. Yes. Yeah. Yeah, great question here. So we glossed over what's going on here on problem 4. Let's come down here, vim quiz.sh. So here our file, hello world, and then our condition here is $foo equals hello. And then we'll make it exactly like the problem and say touch if, like, whoa, where did I go? Like that, and that's everything. Reset ls cat quiz.sh. So this is problem 4 right here, what the quiz.sh file ends up looking like. And here the question is, what if we substitute here this foo variable right here? What if we substitute it? And the answer is that if we substitute it, what's going to happen is that this condition right here will become a hello world equals hello, like that. And when we do that, there's no quotation marks around this. So this is going to give us an error in this shell, and the error is going to be an equivalent to a false thing. So this right here will not happen. So if I do sh quiz.sh, we get this error on line 2 saying hello unexpected operator. That we have the square bracket hello. This world right here is the unexpected operator that we're getting this error on. And so it's not going inside of here and doing this touch if command like that. If I were to edit this file and say hello world like this, here we might think now that this might work. We have hello world on the left-hand side, hello world on the right-hand side, but still we get this error about unexpected behavior. Even though our new program, it looks like this, there's no quotation marks here on the left-hand side, and that's why it's not working. Anytime you have this square bracket right here, it always looks at the very first thing, and then the second thing must be like an equal sign or some sort of operator, equals, less than. Turns out there's a lot of different operators in the shell that we're not going to talk about. But this thing, the second thing must be an operator. In this case, it's not an operator, it's the word world. And so we're getting that error message. If we change this again to put quotation marks around foo like that, then, so that's what it looks like. Then we run it, then we don't get the error message, and the if file does get created. Some of the subsequent problems in the subsequent sections are going to expand on exactly what's going on here. But if there is an error condition somehow inside of the square bracket, then it evaluates to false. Anytime there is an error, then things evaluate to false and you don't go inside the condition here. Did that answer? Yes, go ahead. Yeah.
Know that it would throw an error and then we would write it as if we would just say that the ls is quiz.sh.
Yeah, so the question is for the purposes of the quiz, what do you do? And the quiz problems all state that it only cares about what the contents of what the output of the very last command is down here, this ls command. So it doesn't matter what happens in this command here, except how it affects this ls command. So you don't have to like memorize what the error message is going to look like, or be able to give me what the error message is going to look like, or tell me why there's a problem. You just have to realize that, oh, there's going to be an error inside of this condition right here. So it's not going to run this. It's not going to create this file. Great questions. Yes. The question is that, so previously we said it doesn't matter whether you have single or double quotation marks, or whether it comes from a variable or anything like that. All that matters is what the actual string itself is. Here, so then the question is, why does it matter whether we have quotation marks or not quotation marks around here? The answer is because hello world and hello world, these two things, so these two lines 3 and 4, so the thing in comments is the result of doing the substitution on the thing not in comments. So this is the result of doing this substitution here. This is the result of doing this substitution here. What matters here is that quotation marks group things together into a single string. So this up here is two separate strings. Hello is one string, world is another string. Down here, hello world is one string by itself. And so quotation marks do matter if there's spaces here, but they don't matter if there's no spaces. if we had something like this, this would be equivalent to this down here because they both represent the same string value. So it doesn't matter how you get the same string value. All that matters is that it is the same string value. But this up here is not the same string value as this down here because this is two separate strings, the string hello and the string world, and this is a single string hello world. Yeah, so it is a legitimately very weird thing. Okay, if it's still not like 100% clear exactly when things are the same and not the same in your head, but these are the things to be thinking about. All great questions so far, but especially as you're working through the practice problems, be thinking about these things.
So the potential errors still happen if the EOF is closed.
The question is on problem 4 up here, if this line 3 right here, if this EOF here was modified. Is that your question?
Well, it is in quotes for actual problems.
If we were to take away the quotes?
Okay, this also happens.
Yeah, so the error we were talking about is not related to the EOF quotes and no quotes. It's only related to the contents of the shell script after it gets created. Is that answering your question? Okay. Yes?
Yeah, so for EOF, is single quote separate and
True statement. You could also use double quotes here, which is the same as no quotes. And in general, everywhere in Bash, no quotes is the same as double quotes if you don't have spaces around things. But at least for the purpose of the quiz, it'll either be single quotes or no quotes.
okay, and then like quote
Yeah, the short takeaway answer is that if you have single quotes here, this variable up here does not get substituted. If you do not have single quotes here, this variable will get substituted. If you have single quotes, you'll use this variable. If you have no single quotes, you'll use this variable. I see, yes, you go. Well, no matter what, line 3 does not run the program. Line 3 only creates the program. Just like in our previous quizzes, our cat command here with our doc test did not run the Python code that we were creating. It just created a file that contained the Python code. So line 3 on your quiz will never run anything, no matter what it looks like. It only creates the file that at the second to last line will be run. Does that help? Okay. Section 2 is about without if statements at all, how do these or and operators work? And in Python, it is very rare to see this behavior. It is considered bad practice in Python to rely on the behavior that we're about to talk about. In the shell, it is considered good practice to see this behavior. And so you will see this behavior that we're about to look at far more than you will actually see explicit if statements. And so let's reset this, clear everything about my problem. What we're going to see is that if we have this false command right here, false echo hello world right here, this false evaluates to false. And so in this or command right here, it will continue going on and it will run this command. And we see that it prints out hello world right here. If I change this to true, then the true will be evaluated. And then as soon as we hit the or over here, it'll say, oh, I already know this whole statement is going to evaluate to true. And so I don't need to run this right-hand command over here. This is called short circuiting because we use the condition on the left or we use the statement on the left to determine whether the statement on the right is going to run or not. So up here, this is a false. So in order to know whether this entire thing is going to be true or false, we have to run this thing on the right to see whether it's going to run or not, to see whether it'll be true or not. And so the thing on the right will run. In this command down here, as soon as we see a true result, we see true and then or, we do not have to do the thing on the right in order to know that this whole thing will be true. So by short circuiting, we do not complete the whole circuit. We just do as much as we need to realize this whole thing evaluates to true, and we don't run this command over here. So this is sort of a trivial thing with false and true, but it's common to use your like square brackets. So let's remind ourselves foo is equal to hola. And so we could do something like $foo equals hello, or echo hello world, have some sort of complicated condition, and then only do the thing on the right-hand side if the result of that condition evaluates to false in this case. If I change these to ands, then the behavior is reversed, that we will only do the thing on the right-hand side of the and if the thing on the left was true. In this case, this evaluates to true. And so we do run this command on the left, but if the thing on the left evaluated to false, then we know that there's no possible way that this entire condition could evaluate to true if this thing on the left evaluates to false. And so we do not do this thing on the right-hand side. To make that more clear, true and echo hello world, false and echo hello world like this. Only do this thing on the right-hand side, only do that if the thing on the left-hand side is true. It turns out that in all of the test cases on GitHub Actions that you've been running, all of the commands, what causes the test cases on GitHub to run are shell scripts that are connected by these ampersands. And so it'll be like flake 8 on the left-hand side, like flake 8 of your program, and flake 8. Here, so what GitHub Actions does roughly is do the flake 8 and do the Python 3-m PyTest and a couple of other things chained together. And so it'll stop as soon as it finds one of these things that is failing, and it has to have all of these things succeeding in order for the whole thing to succeed. So that's a little bit of motivation about why this works the way it does and when you might use it. We'll see that in more detail in a subsequent lab. So these inline conditions, again, testing that knowledge over here. The slight weirdness about it from the quiz's purpose is that it also has these output redirections over here. And the output redirections are creating files that are going to appear in the ls command. So let's walk through problem 15 now. So let's reset this, rerun that. And in 15, we start with foo equals hola. So foo equals hola. And then we had false or echo $foo greater than false, true or echo $foo into true, and then the ls command. And so here, this output redirection right here applies to commands that are sort of separated by the ors. So this greater than sign right here, this is the full command that is being separated by these or statements. So when I have false or this thing over here, it says, okay, I don't know whether the whole statement will be true or false yet, so I have to run the thing on the right-hand side. And the thing that it runs on the right-hand side is this entire thing right here, including the output redirection. So it runs this, and we get the false as the output. It actually doesn't matter here what the contents of this variable is, because we're only looking at the name of the file over here. When we have true on this next line right here, it says, okay, I already know that this whole thing will evaluate to true, so I don't need to run this command over here. That includes both the echo and the output redirection. I don't need to run any of this over here, so we don't get this true file created, and we only get the false file created. If I were to change this line right here, if I were to change this line so that the output redirection happens, say, outside of parentheses like this, then this whole thing, the output of this entire thing will be directed to true, and this entire thing will run, and so that would create a file true. But when there's no parentheses like that, it's like the parentheses are grouped around like this, and that does not create anything because the true says, combined with the or, says don't run this stuff on the right-hand side, and this output redirection is part of the things that don't get run. So that's this section 2 of the quiz. It has a bunch of different variations with conditions and the ands and the ors, lots of different output redirections, and the not operator. And that takes us to section 3, this exit codes. Question, yes? Question is, why is this considered bad practice in Python coding? There's this idea in Python that obvious is better than complicated. This is a Python maxim, and this in the Python world is considered complicated behavior. The fact that you only do the stuff on the right-hand side depending on whether the stuff on the left-hand side gets executed. And so traditional in Python to not rely on this behavior. The shell, so when the shell was first being created, well, let's see. So Python, the reason this is like an important thing in the Python world is because the vast majority of people who use Python are not like computer science people, have never even taken, for example, a data structures course. They are scientists in some other field or digital humanities people, and they're just reading the code and maybe not aware of subtleties of behavior like this. The shell was invented at a time when everybody who programmed had a PhD, and so they just, and they were in particular math people. And so for somebody with a math PhD, this doesn't seem like a super complicated thing. And so it was something they came to rely on quite heavily. The shell was also invented at a time when you had to actually be like using a hole punch to punch these commands into paper and feed the paper into machines. And so being very economical with how many characters you're typing makes sense when you're actually having to physically do things on paper. And so the shell just has this culture of it's better to be concise, even if that adds complexity. Good question. Any other questions about anything before we get to the last section? Okay, exit codes are, the intuition about exit codes is that they're kind of like return values that in the shell, programs are like functions. Or here, write this way. Shell programs are like Python functions, and program exit codes are like function return values. So exit codes are the way that programs communicate with the shell to tell them information about what happened in the program. And so we're going to take a look at some examples here. So this first problem 21 right here, what's going on is that so we have our initial same problem up here, problem initialization, and then we are going to use the cat program to create a logs file. And so this logs file is sort of the way to think about it. There's a very common pattern about what we're going to see here. This logs, you can think of it as the output of a program that's been running for a long time. So maybe you have one of these programs that's running on this big Twitter data set. It's taking a couple hours to run. And so as it's running, it's printing out various information. And some of that information might just be normal information that you don't necessarily care about, but then some of it might be error messages that happen along the way. And so if I do cat arrow logs, oops, got my greater than logs EOF here, and then it was info colon blah, error colon blah, 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 info colon blah, like this, EOF. Then it's very common to have, with one of these log files, to want to use the grep command to search through it and find whatever error messages might have happened. So we've seen how to do that before. Something like cat logs gives us the output of the logs program, and we can pipe that into grep and search for, say, either the info messages or the error messages, whichever one we want to be focusing on at this particular moment. In this case, line 8 down here is cat logs pipe grep error, and then it also adds this or statement over here. So cat logs pipe grep error or echo hello world. And we'll start with this without the final output redirection. When I hit enter right here, we can see that this right here did in fact find an error message right here. This did in fact find an error message. So this right here is equivalent to true. Whenever grep does find something, it is equivalent to true. So whenever grep finds something, it's equivalent to true. And so because this thing on the left-hand side of the ors right here is equivalent to true, this whole thing is equivalent to true, we do not run this thing on the right-hand side. If I were to change this to use ampersands and like this, now the thing on the left-hand side is equivalent to true. So we do go and run the thing on the right-hand side. We do get this hello world down here as output. If I were to change this thing that we're searching for from error to say warning like this, warning is not contained in my logs file up here. I have some info lines, an error line, another info line. Warning is not contained right here. So this statement right here will evaluate to false. It will not print anything because there is no warning going on. And since it's false, we will not do this thing on the right-hand side over there. We get no output at all. This is equivalent to false because there is no warning anywhere in our logs. Because grep did not find anything, this is false. And then because of the short-circuiting behavior, we do not run the thing on the right-hand side. If we change this to an or statement, then here, grep did not find anything, so this is false. So we do run this command on the right-hand side, and we do get the hello world down here. The key thing that's different about this section compared to the others is that you have to know this grep command and what its behavior is going to be when it finds things versus not finds things. So again, summary, if grep finds something in the input, it is true. If grep does not match, it is false. Any questions about this so far? Hey, Joe. So then for the purposes of the quiz here, the questions about what exactly to do with the quiz. This, the answer, we'll have to look at both line 8 and line 9. On line 8 up here, we have this output redirection into the file foo. So line 8, what it looks like is cat logs pipe grep error, and then or echo hello world into foo, or echo hello world into foo. And when I run this, we have to be realize that this or groups everything on the left together and everything on the right together. So this file foo right here, this output redirection, it will only happen if the thing on the left-hand side evaluates to false. In this case, grep did find this error in the output. We do cat logs. Here's our output of cat. Here's the error command right here. It does find this. We can see that it printed something right here. And so it will not run this command over here, will not create this foo file right there. So when I run ls, we see that there's the logs file that's been created, but the foo file has not been created because the output redirection, again, this whole thing is grouped together. It's like there's parentheses around this whole thing like that. And so because the left-hand side of the or is false, we do not create the file. If I were to change this problem to have an ampersand right here, then it would run the thing on the right-hand side, and so it would create that foo file. For the purpose of the quiz, it doesn't matter what the contents of this foo file is, it just matters whether it's created or not. And so what this is testing on this ls command right here is, did you understand whether this foo file got created or not created? You don't have to, like line 8 right here, this is not the last line, so you don't have to write the output of the grep command at all. You just have to write the ls command here. Again, a very common way to miss points on the quiz is in the output of your ls command, you forget to put the file that was created by the cat command up here, the logs, and you only do or not do the foo command here. So don't just focus on a command on the output redirection here, also remember the logs or quiz.sh up here. Did that answer your question, Pedro? Good question. Any other questions so far? Okay. So there's a couple of more examples, variations with the inline conditions here. And then in section 3.1 here, we get to putting commands inside of the if statements. And it turns out that any command you can put inside an if statement, and it's 100% okay. It does exactly what you would expect based on the things that we've talked about so far. So I'm going to go through this problem 26 next, and we'll see exactly what's going to happen here. The first line here is the line that we've seen before, just deleting everything. This second command from line 2 to 7 here, this is creating that logs file just like we've had before. So redo that command. I'm going to relook for this logs command so I don't have to type it in again. Here's the same logs, infos, and error. Hit enter. And that takes me up to line 7 right here. Then line 8 is another cat with this EOF going on. We'll have to be careful thinking about that. So cat into quiz.sh in the single quotation marks EOF. And now it's an if statement, cat logs pipe grep error. We'll see this, talk about what this does here in a second, and then whether we create the file or not create the file. So if cat logs pipe grep error output redirection /dev/null, then touch if v EOF like that. I think that's exactly what the problem had. And then again, the first thing to do when running these problems is just to verify what the contents of the actual file you created are before you run the file here. We'll parse through exactly what's going on here. So we have the cat logs. That's just going to output the contents of logs like we've seen before. And we'll pipe that, grep it to error like this. And so that'll output the contents of whether it finds the error or not, any line containing error, and here's one line. This output redirection, output into /dev/null. Output redirection does what we've always said it does. It just takes the output of this previous command and puts it into this file right here. This is a special file, though, that always exists, and no matter what you write to it, though, it does nothing with it. It doesn't print it to the screen. It doesn't save it anywhere on the hard drive. It's just like a black hole that sucks in whatever you put inside of it. So this right here is not going to affect the program at all. The thing that matters is that this grep command right here will evaluate to true because it does in fact find the error up here. And so when I run sh of quiz.sh, this whole thing will evaluate to true, and it will run this touch if statement. We'll go ahead and run ls. We can see that there is no if statement right now. If I do sh quiz.sh and then do ls, we can see now that there is an if statement right here. So all three of these files exist, and that is what the final output is. You'll notice that when I ran sh-quiz.sh, I did not have any output printed. That's because of this output redirection here to /dev/null. There's a common pattern anytime you have a program that's outputting things to the screen that you don't really care what it's outputting. You just want to like suppress it, not print things. You route it to /dev/null. If I were to take that /dev/null away, it wouldn't affect the contents of the problem at all. So the only difference between this version of the quiz.sh and the previous is I took away the /dev/null output redirection. But now when I run the quiz.sh command, it prints this error to the screen. The vast majority of times when you have a command inside of an if statement, you don't really care about the output of the command. You only care about the exit code of the command. And so it's extremely common pattern to see in practice, doing this output redirection to /dev/null inside of if statements. So that's what the output redirection here is doing. And again, the main way, or a very common way to accidentally miss points, is on this ls. We have not only the if file created right here, but also the quiz.sh and the logs file up here. Make sure that you're including all three of those things in the outputs. Any questions about any of that? Yes.
What would happen if warning, like something that was in the log instead of error?
Yeah, the question is, what would happen if, so let's change this command to grep warning like this. So our quiz now looks like that. The contents of our folder looks like that. Cat logs, there is no warning inside of here. There is no warning. So when I run this command up here, grep will not find anything. Grep will not find anything. And this whole thing right here will evaluate to false. And so it will not come inside of here and run this command. It will not create the if file. sh quiz.sh ls. No new file being created right here. Yes. Question is, you need to know this for the quiz. That's correct. Is this commonly used in programming? In Python, the thing that's not commonly used in Python is the short circuiting behavior. Is considered bad practice in Python. Everything that we've seen on this quiz, though, is considered good practice in the shell and very commonly used. Everything in this quiz is good practice for the shell and very commonly used. That answer your question? Just have a minute left, and I'm gonna highlight something that's programming language people get really excited about, but there's not something that you need to know for the quiz or for any of the labs or homework assignments. It's just kind of a cool feature of the shell. And that is that this like false and true and square brackets, these are not built into the shell in any way. Instead, these are all just programs that exist that somebody has written, and they have their behavior that does semantically what we want them to do. And their exit code is what we want them to be. So if I type which false, which tells me where on the hard drive a program is located. And we can see that all these things are just files, programs that are being run. They're just like any ordinary program, just like the grep program. And so when we use an if statement right here, there is no special like false or true built into the shell like there is in Python. There is no special square bracket and conditions and equals built into the shell like there is in Python. These are all user-defined programs. And so some people like define really complicated versions of the square bracket program to do really complicated conditions. Similarly with all these other programs, and the shell is very extensible this way. Yeah, that's a good spot for us to stop for today. If anybody has questions about this or anything else, I'll stick around as long as people have questions. Reminder that for this Wednesday, the quiz is not on Posix Ii. This stuff we talked about today, quiz a week from now. The quiz for Wednesday is the original Posix Shell 1 material. Good luck, and oh, sorry, I went a little bit over.